Okay, so yesterday you guys had the opportunity to read, what is it called? Heating the air, radiation and conduction. About a 5-page short article in your textbook. And remember before that, we had seen that a little bit when we talked about, or when we had that little cold water, red water experiment with those items that you see on the board. We talked about more specifically what was happening at the particle level. If we could zoom in and get a really tiny piece of the water, or a really tiny piece of the glass vial, we could see these things happening. And then we talked about the word conduction. Conduction meant we were transferring energy from one type of particle to another because they came into contact, right? And we talked about 2 key ideas. You remember what those key ideas were? What was one of them? Yeah. What kind of had to do with conduction? One was that heat is really having to do with the transfer of energy, right? So if I get more energy transferred to me, I'm going to be more hot. If I have less or energy transferred away, I'm going to be cooler. The other one was?
Contact?
Yeah, energy transfers through contact, which really is conduction, isn't it? Okay, so 2 main ideas that we had there. We saw how hot water particles from one thing touch another thing, touch another thing, touch another thing, and so you can have items heat up. And really all this went back to what's happening in the air. Right? How does the air around us get warm? Well, it starts by the sun. So we've got this radiant energy from the sun, and it heats up the ground, it heats up the soils, it heats up the trees. And so there is some energy already in the air to make it warmer, but now also this conduction that's happening, energy going away from trees and soil and everything else here and into the air. Luke?
Which would you rather be, hot or cooler? You said you get like cooler or hot.
Well, ultimately everything's trying to become the same. So when something that has a higher energy is transferring its energy to something else it's touching, it's trying to transfer just enough energy so that those 2 things have the same amount. It's a fancy word we call equilibrium. And so ultimately that's what's trying to happen.
Well, I mean like would you rather be cool or hot, like pretty, like cool, like you're cool or?
Yeah, I'm going to move on.
Okay.
All right, so here's what I would like you to do. And you took notes on your reading from yesterday, so you can use your notes, and I would like you to fill out this graphic organizer. At the top, it just says, well, what is heat? 3 things on the side, what's it like? Down below, what are some examples? So I'd like you to take, you can go ahead and turn to that article starting on page 99. You can take your notes that you put with it. You can even partner up with somebody near you to fill this out. It's taking that information that you read and now organizing it in a logical way. Okay, I'll give you about 2 minutes or so. We'll see if it takes longer than that.
When you said about the equilibrium, it kind of seems like if that happened, it kind of feels like communism where everything is equal and so the most.
Yep, it is nothing like that. Okay, you got 2 minutes. You've got the sheet of paper. You can get started. Starts on page 99.
Wait, which one is it?
Take Cat go with you.
What is it like? Oh, no, we're supposed to over fire. What is air?
Wait, what do we do? Oh.
What is it? What is what? Heating, air, radiation, and hot cold, and then give off heat. When something's hot. Wait, heat is not. You know what? What should we talk about? This is heat. Heat can transfer from one place to another. It should be on the first page. It should be on the first page.
What is it?
Oh, I know what it is. This one, the heat particles. When the heat particles on the small.
What is it like?
Particles. It's particles hold like, I'm just gonna say, because that's like a good answer.
What is it like?
What is it like?
What is it like?
It's, oh, it does make sense.
Caleb, are you done?
What is it like?
It's a source of.
Pizza in your mouth.
I just guess a hot pizza in your mouth. Hot.
That's how you spell all the Oh, hot.
That's for one thing. I put it's a source
Heat
of hot
is hot,
energy.
huh?
Then you can put
Really deep thinking there.
I'm gonna try to find a boy.
This kind of looks like your favorite.
I know. Let's just put. It can warm. It can warm us.
No.
It can turn cold stuff to hot.
No. What is it like? That's an example. That's an example. There's an example.
Okay, I would like you and your partner to partner up with somebody else. So become a group of 4 to try to fill out the rest of this if you're having a hard time.
Grace, just come up here. Go to Jenna. Go to Jenna. Go to Jenna.
Okay, Jenna.
Partner up with others. So if you're stuck on something, they can help you out. Let's go with them.
This one particles that heat up. It's one particle heat up.
I put it's energy, but
Are you saying what is it like? A source of hot energy. Are you saying like
Let's go with somebody
particles that
else.
heat up? Yeah. It's
You
a
had
source
a
of hot
partner,
energy.
somebody else had a partner, now you're
That's
becoming a
not
group of 4.
wait.
It's a source of hot energy. I'm also gonna put it's hot. I don't know, what is it like? It can have different temperatures, I don't know. It can get,
Learn anything else besides heat is hot, it's warm, it's heated.
I couldn't think of any other
Look at the text.
okay,
It's not supposed to be just coming up with real thought. It's supposed to be based on what you read.
wait, I put it like examples are, oh, a campfire.
Oh yeah. S'mores.
Like an
Hot chocolate. Pizza out of the oven.
hot on the stove.
That's not nice.
I'm putting it's hot for what's it like?
And what is it?
Light. Not heat, not a pot. What that was like a pot.
You got 30 more seconds, get as much filled out as you can.
Put light. Pizza light. stuff. Especially when you touch it.
Don't try to kick your wall.
Five, four, three, two, one. All right, head back to your seat if you're not there already. What do you have up here? Heat, what is it? Jenna?
It's kinetic energy.
Close. I wouldn't say it's just kinetic energy. Dusty? Movement of kinetic energy. Okay. Put those two together.
Particle motion.
Particle motion.
Kinetic energy produces the heat.
Okay, so maybe the amount of kinetic energy would have been a better way to say that, and that can move. Kinetic energy is, you see movement of particles, which is kinetic energy. The amount of that you have is the amount of heat you have. And then down at the bottom, what are some examples? Here's four that I came up with, and I think I saw most of these on yours. Really, if I'm looking from the textbook, they said, well, when you pour milk into hot chocolate, some of the energy transfers from the hot chocolate to the milk, right? So it starts evening out, and overall it cools down. Gas stove that's got a flame, it heats up the bottom of the pan, which heats up the water inside it through conduction. Hot pizza burns your mouth. Some of the energy, the kinetic energy transfers from the pizza to your mouth when you touch it through conduction. The other one was not conduction, but radiation. The beach is hot because you got the sand and the water that were warmed up because of the sun, and that goes to the air. Anything else that you had that I didn't just list? Yeah.
Campfire.
Campfire, sure, any kind of fire that has is burning. The particles around it have a lot of kinetic energy.
Hot chocolate.
Okay.
When you eat hot pizza, then your mouth is like.
Talked about that one already. Yep.
The sun.
The sun is heat. Is that true? Yeah, produces a ton of energy. That's where we're getting most of it from. I thought this section and this section were probably the easiest. What is it like was maybe the most difficult. And I saw some of you, well, what's it like? Heat is hot. Well, yeah. What else could we say about heat? Luke, you had a couple good ones.
Flows and is not visible.
It flows, so it transfers. It's not visible. Yeah, you can't see heat. You can see the effects of heat.
Heat is heat.
What else do you have, Mac?
When solids get hot, the particles vibrate more.
Okay. So you're talking at the particle level, what's happening. Braylon? Yeah, and cold really isn't a thing. We use the term cold, and we know what we're talking about, but really there is such a thing as heat. It's the amount of kinetic energy. Cold is just the lack of heat, right? I can't give you cold, but I can give you heat, right? Because it's transfer of something, energy that's there.
Oh, so it's hot energy.
Okay.
You can give somebody cold.
Cold.
Not a cold. I'm not gonna get them sick.
No, if they have cold hands and you touch their neck,
Let's talk about that.
they go like this.
Yeah, so did you make them cold? Sure, that's the phrase we use, but that's not really what happens, right? If you've got a really cold hand and you touch somebody's neck, what's really happening?
They're getting you.
Yeah, the direction of energy transfer, the hot, I shouldn't say the hot particles, but the particles, the kinetic energy is leaving somebody's neck and going to your hand. The lack of heat then is what makes that neck feel cold. Which seems weird because it feels like we're giving them cold, but actually we're taking away their heat. Okay? Caleb?
Fast. Because like the particles go faster when something's hot.
I didn't miss what you said at the beginning of what?
Fast, because the particles go faster when something's hot.
Okay, sure. All right. Any questions from the article? I think for the sake of time, I wanted to do something else. I had a few other questions about the article, but if we don't have questions, I'm gonna go past that. We came to the end of part 2. We're gonna do kind of a review, which is part 1 and part 2, and then the rest of the time we're gonna spend, getting our website in order, okay?
Favorite teacher.
Right now, you can go to, kahoot.it.
Favorite teacher be like?
Why? Because we're doing a Kahoot.
No, you're just always my favorite teacher. Becky.
Here's the game pin.
Can I sit up there?
There.
I'm blind, yeah, I know.
9504093. Well, you don't all need to do that. No. She asked. You don't need to. You're sitting in the middle of the classroom, Destiny.
I'll go
My
sit
goodness.
on the floor. I can't see that.
Sam, if you need to move up because you are way in the back, unlike these yahoos that are like, can I sit 2 feet closer? No. If you need to move, you can. David, can you see back there? Yeah. That's amazing. He can see. He's like 15 feet further than the rest of you.
He has good eyes.
Yeah.
Hurry up.
That song is annoying.
Let's go. This song?
Yeah.
Yes.
I like it.
Can you change it?
I can turn it up louder.
Yeah.
Yeah.
Look at that.
No.
At
Backfire.
13 of you, we got what? 2, 4, 6, 8, 10, 12, 14, 15. We're starting in 5, 4, 3, 2, 1. Here we go. Differential heating. This is the start of last part. Different materials heating up at different rates. The same material heating up at different rates. The length of time it takes for something to heat up. The amount of material that you are heating up. Did that help when I read it really fast?
Wow.
Wow.
Differential heating. Can you give me an example on that one? What did we talk about last time? You saw a little kind of animation thing about this too. Jenna.
It's not working, we don't have any points.
Okay, too bad, so sad. Tell me about differential heating. Give me an example of how different materials heat up at different rates. David. Yeah, they're both a bucket of sand, bucket of water in the hot sun all day. What's going to be hotter? Sand, right? I did not say sand.
A bucket of sand and a bucket of water.
Haley, you're in first place. Radiant energy is what? When you think of radiant energy, what do you think of? Travels through electromagnetic waves. Where do we get what's the big radiant energy thing? It's big yellow and orange ball. It's in the sun, it's in the solar system. It gives us heat. Yeah.
Jupiter.
Okay, so radiant energy, think of the sun.
What about the yellow one? Wouldn't that be correct?
That you can't see, yeah, it wasn't the best answer though. Radiation is energy transfer that happens only at night. That's sneaky radiation. No.
Oh no. I guess
Oh, boy, we're all over the board. Yeah, it only happens when items are touching? No, that's conduction, right? Who's talking about that? Happens only at night? That's just a weird answer.
Who picked that?
It happened when, yeah, that's true.
Who picked it only happens at night? Me.
I tried to do that one, but it wasn't.
Okay.
They were on there. Well, we're all gonna be winning.
Conduction is energy transfer. That, I just told you this one.
Everybody's gonna win.
Imagine somebody.
This one.
Wow, I
He
got
just
one
told
question right.
He just told us.
Yeah, why are we taking so long to answer? Okay. Hey, we got
Oh
that
my
one.
gosh.
I knew it answered.
Yay, everybody.
Radiation is energy transfer that,
Radiation.
oh, re-radiation. I don't think we talked about this one. You can just guess. I can just skip it.
Oh, good.
I'm guessing.
I guess.
I'm actually right.
Helps to heat the atmosphere. Energy transfer always happens between objects. When it happens, it go from hotter to cooler, from largest to smallest, from cooler to hotter, from smaller to larger.
I'm just guessing.
Oh my gosh, I got it wrong.
Take a guess.
I got it wrong.
Because if you
Okay,
guess, then you'll remember, oh, that's what the right thing was, or oops, I got it wrong, here's the right thing.
Yeah, I know I got it wrong.
Do what?
It's not fun without fun.
It's not very
I'm
long.
press playing.
Oh, I got it.
Always, always, always. Energy transfer from hotter to colder. So going back to Trey's thing, and I put a cold hand on somebody's neck. Really, the energy transfer is from the warmer neck to the colder hand.
Mrs. Taylor does that to Mrs.
Nelson.
That's funny.
That is funny.
Uh-huh.
She's
Which of the two metal bars that we worked with was a better conductor of heat?
Oh, this will be easy.
Conductor, well, I'll save that question for later.
It's titanium.
Aluminum.
Did you actually pick?
What does that mean?
No.
What does that mean that it was a better conductor?
That it heated up.
It doesn't even matter.
That the energy
It doesn't even matter because it's hot.
by it, that the energy transferred throughout the entire object, right? We heated up one end, and all of a sudden the other end was also warm.
What if we use titanium too?
It'd be a whole different experiment, wouldn't it? Which of the earth materials that we worked with heats up and cools down the fastest? Don't put
But it,
water.
it's glitch.
Oh, okay.
It's not water. That does
Mine's
not heat up and cool down
What
fastest.
do I do, Mr. Guy? I pressed the wrong thing.
Go to kahoot.it. Name pin is 9504093.
Okay, I need to leave. I did it. Me too. I'm insane.
Which of the earth materials that we worked with heats up and cools down the slowest?
What's Oh no, now it's working. Oh darn it.
What?
I picked water.
I did it.
Correct.
Two got it wrong.
Correct.
Yeah.
If a container of water has heat applied to it, the water molecules will start to move faster, slower, in the same direction, move to the bottom.
Now I'm making
I know. Actually, I don't.
Oh,
Faster. Okay, remember, let's see if I can do this here.
I have an answer streak.
Remember this? And we warmed it up and suddenly these little particles started going a little bit faster? That's what we're talking about here.
Okay, Mr. Gunn.
Holding an ice cube in your hand is an example of conduction, radiation, convection. Well, we haven't talked about convection yet, so it's probably not that one.
Oh.
Then why'd you put it?
Dang it.
If we didn't talk about it.
Give you some options.
But if we don't know what it is, then we're not gonna pick it.
Why would you pick it if we've talked about conduction and this is an example of conduction?
And why'd they pick radiation if we just said what
So
radiation?
ice touching a hand and then there's heat transfer.
This thing is hacking.
Yeah.
Is this one that we don't know?
I know what it is. It's red.
This is my best
Yeah,
guess.
it's red.
Wait, that's actually what I picked.
I got it right for once.
Da, da, da. Alright, head back to your seats.
I won.
There's a little purple smiley face.
Did we have one?
Okay,
Little purple smiley face.
you have 6 minutes to start your assignment, which is due Friday, because tomorrow we don't meet. Okay, your assignment is to complete everything on your web page from Investigation 4, Part 2. Here's what you could do if you want. I gave you that template that had all of our investigations, but we're starting this a little late. So if you want to totally delete the first and second and third sections, that's fine. And all you're left with is Investigation 4 and 5. You don't have to, but I thought that might be good. Add your driving question for investigation 2, part 4. Your driving question I'll put back up on the board. How does energy transfer to the air? Okay, that's what'll go there. Add your proof, which was pictures of the experiments that we did. You can now maybe take a picture of something like this. Okay? You could take a picture of the other little sample that we did yesterday with the two bars. Okay? And then you're writing about that. And then a reminder, don't forget to publish everything at the end. Okay? Can you fill out the section on the textbook? Yeah, we just did that. Okay, so you'll have that whole section filled out. So there's a decent amount of work to do. Okay, you can get started on that right now, and I'll try to come around and answer any questions that you have.